Hi there, and welcome to your review on vectors. So at this point, we've done the lesson and the assignment as well. And so I want to kind of run through a few things just to review in preparation for your quiz or really your check for understanding that you'll be doing on Friday. So first of all, we would kind of say that vectors have two things. If you recall from our class, so they have both magnitude and they have direction. We indicate that magnitude often by looking at the arrow, and the size of the arrow indicates whether it has more or less magnitude or size than another vector would be. The direction helps us kind of know which way it's going, whether it's going this way or whether it's going this way or this way or this way. So direction is helpful as well, which is usually indicated by some sort of a degree, like 10 degrees or something along those lines to help us know what the angle measurement is going to be for that vector. Now, the components of a vector are the two parts of a vector that are perpendicular, perpendicular. I think it's an E. I don't know. I can't spell. Perpendicular to each other, meaning that one goes this way and one goes this way, forming a right angle at some point. Okay, that's the perpendicular part there. So you're going to have a right angle formed, and that's how you have the two parts of the vector. Now, the resultant vector is the sum of two or more vectors. Sum is a nice fancy word for meaning we're going to add things together. We're going to put those vectors together to find the resultant vector. So we're going to add them up. So yeah, and we find that usually often with the Pythagorean theorem and things like that, but we're going to be adding things together. Now, the sign that the component depends on the quadrant that the vector is in. We talked about the coordinate system here being 1, 2, 3, and the fourth quadrant. And when we talked about those, we said that over here, our x values are always going to be positive, and our y values are positive. When I move to the second quadrant, because I'm kind of going this way on my x-axis, my x values are going to be negative, and my y values are still positive because we're still going up this way. And when I jump to the third quadrant, though, everything is going to be a negative value, my x and my y. And in the fourth quadrant, my x is positive because we're on this side of the x, and my y is negative because we're down here. So keep that in mind because when you're looking at a vector, if the vector happens to be, over here, we would expect to have values that are both going to be negative. If my vector was over here, I would expect a x value that's negative and a y value that's positive. If my vector was over here, I would expect an x value to be positive and a y value to be negative. And finally, of course, if I had one over here, I would expect both to be positive. And this way here, you see, anytime you have an angle measurement, that's going to be somewhere around 90 degrees. If the angle measurement is 90 degrees or less, then we're going to expect both components to be positive. Once I have an angle measurement that's more than 90 degrees, right? Let's say even if it's like 95 degrees and it's over here somewhere. Once I cross this line, I now have a negative vector there. If I keep getting larger, I have two negative vectors. And I can come all the way over here and swing it over here, and I still have a negative vector. So the only way to end up with two positive vectors, or two positive components, sorry, is going to be if the angle measurement is less than 90 degrees, meaning if it's more than 90, I'm always going to have one negative component. So it says think about the quadrants and the values of x and y. The x and y components of the vector are only guaranteed to be positive if the angle is located in the first quadrant and is less than 90 degrees. We use the Pythagorean theorem, which is the a squared plus b squared equals c squared, to calculate the magnitude of a vector. And we did that using something like r squared equals rx squared plus ry squared. And that's how we did that oftentimes in our problems. But in order to use the Pythagorean theorem, we need to have a 90-degree angle, or we could call that a right angle. But I need to make sure that one of the angles is at least going to be 90 degrees in order to use the Pythagorean theorem. We use the Pythagorean theorem oftentimes to help us find out the magnitude of the resultant vector. So here's an example where I have a 90-degree angle and I have a vector going maybe north, like 4 miles per hour or something, and then going to the west, 6 miles per hour. And I end up with this resultant vector right here, this amount, which I don't know what that is. So to find out what that is, because that is the one directly across from the right angle, that is my hypotenuse, I know that 4 squared plus 6 squared is going to equal my hypotenuse squared, whatever that happens to be. So 4 squared is 16, 6 squared is 36. When I add those together, we get just a lovely number, 16 plus 36, and we get 52. Now 52 is equal to our hypotenuse squared, right? Or we might call it our resultant vector squared, however you want to think about that for your formula, right? But I don't leave it as r squared. I need to make sure I take the square root of both sides in this case. And so the square root of 52, if I use my calculator and use the second function, I can make this a square root of 52 and find out, oops, sorry about that. Find the square root of 52 in my case here is equal to 7.21, and the nearest tenth means I'm just going to leave it at 7.2 equals r. When you do the quiz, I think they're going to have a lot of whole numbers, so you won't have a lot of calculations to do. But if you did need to do that, there you go. Now, vectors a of x and a and y in this picture over here, all right? Here's a of x and a of y are both components of a, meaning that these two parts here are going to combine together to give us this resultant vector here. We can use the Pythagorean theorem to help us solve for the components that are not given. So here are two right angles, and we can see in this case, we have our hypotenuse given there, and this one here with the hypotenuse given there. So we can think of it this way. If this is going to be my r of x, and maybe this one over here is my r of y, r of x is going to be equal to the hypotenuse squared minus the other leg squared. And I get that, if you recall, by saying something like r of x squared, oops, squared plus 8 squared equals 17 squared. And if I subtract 8 squared from both sides, that's how I end up with rx squared equals 17 squared minus 8 squared. I just kind of like did it there, just so it's already done. So 17 squared is 17 times 17, which is 289. 8 squared is 64. So if I do 289 minus 64, I end up with 225 for my rx squared. And once again, I don't leave it there. I need to take the square root of both sides to find out that r, in this case here, is equal to 225 square root 15. For my next one, I once again can see I have my ry squared this time, right? It's going to be equal to my hypotenuse squared, 13 squared, minus this other leg squared. So 13 times 13 is equal to 169. 12 times 12 is 144. So 169 minus 154 equals 25. So my ry squared is 25. And once again, I'll take the square root of both sides so that ry equals simply 5. And so this value here is 5, and this value over here would be 15. All right, so make sure you're comfortable doing the Pythagorean theorem to find out those missing angle measurements there, or leg measurements. Now this next one says, what are the values of rx and ry in the graph below? Now it's a little small here, so let me zoom in a little bit here. So my Rx value, to find Rx, Rx is going to be equal to AX plus BX plus CX. And in my case here, I can see that I have a grid. It's a little bit sketchy there, but I have AX goes out 1, 2, 3, 4. B of x is going out over here, 1, 2 in this case. We're just going to call it 2. And C is going out 1, 2 as well. So we're going to put a 2 there. So my combined R of x in this case is equal to 8. For my combined R of y, that's going to be my A of y plus my B of y plus my C of y. And A of y is going up 1, 2, 3, it looks like. I'm missing kind of a line there, hard to say, hard to see it. B of y is going up 1, and C of y is going up, I should have another line right about there. 1, 2, and 3, it looks like. So my R of y is equal to 7. Those become my values there. And we use that in order to essentially find our resultant vector, which is this purple line right there. It's kind of cool, right? Because if we combine those vectors together, the red one here and the green one here and the orange one here, we end up with the resultant vector there. Now, the resultant vector should be something like r squared equals rx squared plus ry squared. And so we could multiply those together and add them up to figure out what our resultant vector is going to be. Now, take a look at this one here. I put this one here because it's kind of fun. It says fill in the values for the vectors based upon the graph below and then determine the r and x. So first of all, we have our first vector, which goes from here down to this point here. So we can see it's moved across 1, 2, 3, kind of negative 3x over there. We've also gone down 1, 2, 3 as well. So I could say my a of x value, if this is my a of x value here, it's really about negative 3, and my a of y is also negative 3. For the b value, we're going from this point up to this point. So in terms of my x movement, I've moved from, if we draw a little dash line here, here, we're going over 1, 2. So I've moved 2 spaces there. And the y, we've gone up 1, 2, 3, 4, 5, 6. So I'm going to put a 6 there. And then finally for my next one here, my C, I can see I'm moving over 1, 2, 3, 4, 5. Wow, 5. And I'm moving down in this case from here, 1, 2. Yep, I think that's it. So in terms of my R of X value, R of X, for R of X, I'm going to add up all my X's, A of X plus B of X plus C of X. So I have a negative 3 plus a 2 plus a 5. So negative 3 plus 2 is negative 1. Negative 1 plus 5 is positive 4. If I do the R of Y, I have a negative 3 plus 6 plus 2. So I can think of this as 8 minus 3, which is 5. So I have an R of X value of 4, an R of Y value of 5 in that case there, which is kind of like at the sum of all those different components. All right. The second thing we did is we talked about sine, cosine, and tangent, just to help us understand a little bit of the trigonometry that goes into determining these unknown components. And so we learned that the formula to find the sine of an angle was found by taking the opposite divided by the hypotenuse. The cosine of an angle is found by taking the adjacent divided by the hypotenuse. Not sure what that crazy line's all about. Hypotenuse. And the tangent is found by taking the opposite over the adjacent. We call this, remember, SOHCAHTOA. And then we use that there to help us find out missing measurements. And so our idea here was that if we took a right angle triangle like so, and we looked at the right angle, the line across from that is referred to as our hypotenuse. And that works no matter which where your triangle is going. You draw a line across from the right angle, and that becomes your hypotenuse. And then we took a look at our angle, our theta, which was here. And theta was just that Greek word, which is just a letter. And if we go opposite of the angle theta, that is our opposite. And so here, this one becomes the opposite there. And then the remaining line is what's referred to as our adjacent. Adjacent. And so we use those terms there, adjacent and opposite and hypotenuse to describe the triangle that's made there. So when we are looking at angle measurements and vectors, when a vector does this, we end up with an angle here, and we actually end up with some triangles here and here that help us figure out, and we can figure out what those values are for those other components. For the, if this was r, we talked about this being r of x and this being r of y, and we use the uh, the equations here for sine, cosine, and tangent to help us figure out what the r of x and r of y are. So we'll keep it as simple as that, just a little recap on how that worked there. If we want to find the angle of the resultant vector, that's the angle of something, then we want to use the tangent formula. And so we'd find the tangent of theta is equal to ry divided by rx. All right. And oftentimes when you do this, if you recall, you end up with a number. We talked about having it being like, if ry was 4 and rx was 5, you'd end up with tangent of theta equals 4 divided by 5, or tangent of theta equals 0.80. In order to figure out what that is, you'd have to use your calculator and do the inverse tangent minus 1 of 80 to find out what the actual answer, what the angle measurement would be. Now, moving on, looking at the harder part of the lesson here, we're going to try to make this a little simpler today. If we're trying to figure out the components that are in the east or the west of something, all right, so think about back to our example drawing so far. We've had them looking like this, right? And we've had our R here and our RX and our RY. When we want to find east or west, we're talking about something that's usually on that x-axis. So as a result, we want to use the Rx formula, which was the resultant vector times the cosine of theta. That'll help us find the east or west component of whatever vector they give us to work with. If we want to find the north-south, that's going to be the ry component, and that's going to be simply r times the sine of theta. That's our basic formulas that we're going to use in doing kind of the harder math problems that are part of this, besides the ones of Pythagorean theorem. Remember, the key with all this, of course, is that we want to go back to our coordinate plane. And if we have an angle that is maybe perhaps over, let's just say it's here, for example, and it is 20 degrees west, oops, sorry, west of north, then I want to make sure that I'm including all of this from there to there as part of my theta angle measurement. So this becomes 90 degrees right here, plus an extra 20 degrees for a total of 110 when I'm working with trying to find those components. So my R value and my theta value, right? With thetas and Rs, they're always going to give you an R value in the problems, and they're going to give you an angle measurement. But sometimes you have to do a little extra work to find out what the full angle is going to be, starting from the x-axis down here, making that arc. Let's do some practice with those. Here we go. So for the following problems, use the coordinate grid there to draw the vector and angle described. Next, draw an arc to determine the total angle value to use as your theta. And the equations we can use, if we're looking for the east and west, we're going to use Rx equals R times cosine theta. And if we're doing Ry, we're going to be looking for north and south, doing R sine theta there. All right, let's just take a quick look here. We have Jahan Road 10 miles per hour, 30 degrees south of west. So here is west, here is south of west. So he's going to go 30 degrees south of west. So there's our vector. We said that it was 10 miles an hour, so I can make this a 10 here. And in terms of the angle here, We know the angle they gave us is 30 degrees, so I can put a 30 right there for now. Now, directions said to draw the vector, check, and the angle, check, and then draw the arc to determine the total angle. So our arc is going to be from this point here all the way around to here. That's the arc we're talking about. Because right now, we know what our r in a sense is going to be. That's our resultant vector of 10. We want to find out what our theta is going to be. The theta is going to be everything all the way up to this point right here. So I have a 90 degrees here, a 90 degrees here, and we have the 30 degrees we're talking about there. So a 90 plus 90 plus 30 is going to be equal to 180 plus 30 is 210. So to find my southern component, we talked before about if I want to go southern component, I want to use my RY equation there. So I'm going to say RY equals R times the sine of theta. So in this case here, it's 10 times the sine of 210. And if you use a calculator there, you're going to end up with R of Y equals -5. Okay, and that's the southern component, which makes sense because we're down in the third quadrant over here. 1, 2, 3. So our x should be negative and our y should be negative. And so indeed, our y is a negative value, -5. Let's take a look at the next one. It says, Tasha flew a plane 25 miles per hour, 10 degrees west of north. So here is north. We're going to go west of north that way, 10 degrees. And again, we're not trying to draw a perfect line there, but it's there. So there's 10 degrees west of north. And we know that our resultant vector right now is 25 miles an hour right there. And in terms of our overall theta, it's going to be from here all the way to there. So we're going to have a 90 plus 10. So we have 90 plus 10, which equals 100. Because I'm going northern, which is going to be once again kind of the up down, right, type of thing. I'm once again going to use RY for a northern, and I'm going to say RY is equal to R times sine of theta. So my R is 25, and I'm going to do the sine of 100. And so now when we plug that into our calculator, 25 times sine 100, I end up with RY equals 24.62. That's what I end up with there, which makes sense for going up because we're going to have a positive value because here my x would be a negative and my y should be positive. So that makes sense for a positive 24.62. Take a look at the next one. Here, we're going to paddle, Muskan's going to paddle her canoe at 7 miles per hour, 15 degrees south of east. So here is east. This one's a little trickier. We're going to just draw it here for now. And we're going to say this is 15 degrees south of east. Now, we know that our r vector is going to be 7 miles an hour. Got it. In terms of our theta, theta is a little trickier because we're going to go from here all the way around to there. So I know I have 90 degrees there, 90 degrees there, 90 degrees there. That's a total of 270. But then I have this extra piece here. This piece is not 15. This was 15. So what remains is actually going to be 90 minus 15, which is 75. So that measurement there is 75. Let's add that to the 270 we already used. So we actually have a theta of 345. Now in this case, I want to do the eastern component. And when I want to go east or west, I'm going to go ahead and use the cosine. I'm going to go to the Rx value. So Rx is going to equal R times cosine of theta. My R was 7. My cosine was 345. And so we just type it in 7 times cosine 345. And we end up with R of x equals 6.76. And that makes sense once again because we're over here in the fourth quadrant And our x value should be positive and a y value be negative. So indeed our x value is positive. If you wanted to check it real quick, you could do 7 times the sine of 345. Oops, 7 times sine 345. And that should give you a negative number, which in fact it does. 7 times the sine of 345 is actually negative 1.81. And so that's that negative value that makes sense for that quadrant. We don't need that for now, but if you had to find the southern component, that would be what it would be. All right, let's take a look at one last one. Sophie drove her car 40 miles per hour, 30 degrees west of south. So here's south, west is that way. So we're gonna go 30 degrees south of west, something like this. So this is my 30 degrees west of south. So that's where the 30 is at there. So be very careful. That's where our 30 is at. So now when I draw my arc, I'm gonna start here and go all the way around from there to there. So once again, I have 90, 90, but I don't have 30. I have 90 minus 30 for what's left over right here, which is 60. So my resultant vector is the 40, and my theta in this case is 90 plus 60. So 180 plus 60, which is 240. Now I look at what they want me to do this time, western component, which means I want to go east-west. So I want the Rx value, and Rx equals R times the cosine of theta once again. So we're going to say 40 times cosine of, oops, 240, not 24, of 240. When we multiply that out, we have 40 times cosine 240. And I got an answer of Rx equals negative 20. And again, we're in the third quadrant, and so my x should be negative, my y should be negative. So that looks correct right there. All right, so that's kind of the idea. That's really all they're going to ask you to do. They're not going to have you do all the extra stuff we did on some of those harder problems. That's pretty much it in terms of reviewing for the quiz, as far as I can tell. All right, so that's it for today. Have a great day, and we'll see you next time.